So there's no prizes for guessing what we're doing today. It's another one in a box from the same customer who seems to like to have box sets. So it's supposed to be relatively much of a new old stock. It's come with the mic, which can stay there, and these, just for everybody's information, these were packed upside down in the box, so you know it should be speaker side up when it's put in the box, so it just fits better. People realise that. So put the box to one side. Oh, it's got feet on it again. They fell off the last one. Going to need a sheet, and I'll get it connected up and just see what it does as it's come to me. So we did the York 863 from this customer last, and there was a dirty preset for the low power, and there was a dirty volume control. It was only doing 3 watts, wasn't it? The receiver was pretty spot on. A little bit there was to the detector. So we're going to do the same with this one. We've got some other repairs on hand. I can't do all those box sets. I think we're going to do them every other. I think we've got 5. So there's 4 left to do. But we have got other sets to do, and I'll tell you for a start, we've got a couple of Maxcom 16Es. So we'll get those interspersed. And we've still got some D'Amico convoys in from the trade, and we've actually had parts for one of those. Right, so we're all plugged in. I'll switch it on. 13.8 volts. Let's come on 19. That's dirty. Good. I have to get myself a service sheet so we can tick off as we go. Just a point about some of the box sets, if they're Uniden chassis, you're going to need to change those capacitors, the two 220s and the two 240s, before trying the set. They're so problematic. Once that's done, the set should be more or less working. I think we're on 23rd today. Okay, so put picture in picture on. I need to disappear off in 5 minutes. We'll get these initial parameters and the VCO done, then I'll have to get on with something else. So it's doing more than 3 watts. It is doing 3.05. Can you see a pattern? .85. So low power. Go to the other scale. 110 milliwatts. Back to full power. 920 milliamps. Switches with a star tone switch not working, dirty question mark. I'm sure it's not been turned into something else. Wallow. Oh, we need to be on channel 20 to do that. Wallow 1.8, put that in brackets kind of thing. Frequency, test gear's been on for quite a time, certainly more than the half an hour required to get an accurate reading, and we have got 2779107, not far out. So with that in mind, we'll put the signal generator on exactly the same, 27. .107. Right. So we'll put the SINAD meter on, put our camera for the SINAD meter on, and let's see what we've got. Oops, that's PA. We'll just test PA while we've got it in PA.
Testing 1, 2.
Testing 1, 2. And the volume control controls it, which is even better. I don't think I'm being silly there, because there are some sets it doesn't. Okay, back to what we're doing. .12 dB 0.32, another good set. .24, and for 20, 0.7. It's well worth looking in my back catalogue at Cobra 29s. That swish looking one from about 4 years ago. You know, you look at a good one, you're looking at 1.2 microvolts. Absolutely atrocious receive sensitivity. Right, squelch. So on full squelch, let's go to the attenuator. I want to be able to, there's the top of an oil aerosol there. What I want to do is to open it at 100 microvolts. So 1, 3, 10, 30. It's opening at 2 weak. It's opening at 28. Not strong enough. Now threshold is probably going to be excellent. So signal generator to standby, squelch to threshold. Signal generator back on. 0.52. Okay, so we'll just do 2 more things, and that's look at where our signal meter is. It's supposed to be calibrated to S9 at 100 microvolts. It's absolutely spot on at 100 microvolts. And when we press transmit, what does the meter say? It says 3.5, which is probably about right, because the set's doing 3.05 on that channel. Remember, it's a relative power meter, so it's only true into a dummy load. 3.5, and that's correct. Meter lamp's working. So we'll get it opened up, we'll do the VCO, and then I'll disappear. You can see it isn't new because there's scratches around the mobile bracket. but it doesn't have any indications of being messed with, other than we don't have the tone switch working. But that can be just dirty, or it can have been messed with. Mr. Chippy wants to know where his green cloth is, but I don't know. So I'll get my nose in there. Still smells of new radio. And is there any reason I can see for the tone switch not to work? Not offhand. So we'll put some we'll put some service or switch cleaner on that. No, it said WD-40, that would be an error, not suitable. Just waggle that around. That's all it was. Tarnished contacts. So that's done. So we'll just do this VCO. We want channel 40. We want a crocodile clip lead. It's got the earth strap there, which is helpful. We want the resistor R4 far end. We want 4 volts on the meter, it's 4.3. And in transmit we want 4 volts. We've got 3.3. So that's 4.07. Let's go back to receive. 4.08 transmit. So we'll go to channel 1. Should be 1.7, 2.3-ish, 2.4. Transmit, 2.3. Receive, 2.3. Absolutely fine, that's done. A little twiddle there. You can lose your channels at the extremes in different temperatures. If that's not attended to, and even more so on the Cybernet 002F chassis used in the genuine Amstrad. We'll just tick that off. So it's now 4 plus 4. What was it? Something like 3.2 plus 3.6 or something, wasn't it? 4 plus 4.3, something like that. So let's just start the transmit. And I want the camera 1. So we're on channel 20, we want the centre of the peak. So we're not just looking for the peak, it's the centre of the peak. It. So we'll just do the transmitter, I think. So with the blue tool, so back as I keep saying, these sets really need to be able to do 4.4 watts and able to do the tune-up, and then we drop it to 4 watts. The manual says 3.8, but the legal limit's 4, so we're jolly well having it. Never leave it at the maximum it's capable of, because it isn't actually capable of that at all. It's just part of the tune-up procedures that's on top of the job, and it will balance. So we want maximum on this one. That's brought us up to 3.7. We want maximum on this one, which is about 3.8. We want maximum on this one. That's doing. He's actually doing 4.4. Go through them again, because they're interactive to some extent. Sets which have been turned up to service mode, as we kind of call this. So at the moment this is doing just a shade under 4.5. If I left it like that, apart from the illegal side to that, the spirit emissions would come up. The other thing is these coils would start getting hot. What you find is you come to a set that's been tweaked up, in inverted commas, and these have melted and they won't adjust. And of course now you can't get the coils, and the only source now is scrap per set. So we want to adjust this to 4.4. We're only at 4.5 anyway. So I've turned it clockwise so we'd get the 4.4. I've probably got it a bit more at 4.35. Now we drop it by anti-clockwise with the green one. So we're now a good 4 watts. So clockwise for 4.4, we leave that one alone. Anti-clockwise, the manual says 3.8, but we're allowed 4, so we're jolly well having it. Okay, so we were just about to see what we'd got when I had to go and disappear. So an hour later we're back. So we've got 4 watts on channel 20. Let's go to channel 40. We've got 4 watts there on channel 1. We've got 4.05. I'll tell you what, we'll put 4.03 because it wasn't quite. It's now drawing. Go to channel 20. 1.236. And our low power is now tiny. I think it's going to be a case of the service oil switch cleaner on that. Sometimes we have to replace them, but I don't think the set's been used enough for that to have failed. That's now 400 milliwatts. We'll do the frequency next. So let's take the camera to there, and 2779118 hardly needs moving. That's the wrong way. 2779126. It's just slightly above because it dropped with aged. Let's do deviation with the test set behind me. Did I switch it on? No, I didn't. We won't do the deviation. We'll come back to that in a few minutes. Let's do the meter preset for the RF meter, which is there. Put it on high power, it does help. There we go. Put those trimming tools away. Right. Let's have a look at the receive. RF gains at full. Let's go over to the oscilloscope. First of all, we'll put the signal generator on 2779125. So with 100 microvolts on the signal generator, we want to make sure we've got maximum recovered audio from the detector. So I had a query. I'm going to have to discuss some of these terms, because you've got you've got an AM FM set, you've got an AM detector, you've got an FM detector. It's the bit of the circuit that kind of pulls the audio from the receiver. I'm going to have to explain this better, but we need this to be peaked, so you can see the oscilloscope trace there. That's going to be maximum. So if it was like that, it would be garbled on receive. You see, and you've got this, got to hit that peak. This is why we're using a CRT oscilloscope as well. These were brand new 2 years ago, because I was scared that we're going to come to a stage where there were no more CRT oscilloscopes, and it speeds me up, because a lot of the digital instruments with LCD screens have got a lot of latency, and it's a just wait. I don't want to do that. So that's the detector. Let's now do the sensitivity using this SINAD meter. So it's signal to noise ratio plus noise, and the more to the left the better. So we're going to set the attenuator on the signal generator till we get about 4 dB, so we don't saturate the FM receiver. If we were tuning up AM, you could do it without a SINAD meter, you can do it with an audio output meter. I've shown that before. There's lots of stuff in the back catalogue. So we'll go for the first adjustment, which is under this wiring harness. Oh, look at that. It looks like the factory didn't bother moving the wiring harness. It was already working well. Now sometimes you get the extra circuit that you get on the Rotel 240 and the York 863 and some of the other ones, but on this one you haven't got the extra circuit, so this is exactly the same as the Rotel 220. So that's interesting. It is 50-50. Some Rotel 230s have the extra circuit, some don't. And it's to do with selectivity, in other words, bleed over. The biggest signal now to do these IFs. IF stands for intermediate frequency. With two intermediate frequencies, one at 455 kilohertz and the other one at 10.695. So if I get the pink calculator out, this is why, there's people who will change the synthesizer's reference crystal to try and generate illegal frequencies. So I'm not talking about legalities, everything has to be spot on with me, but this is the maths. So if we have 10.24, so I'll put that in my pink calculator, 10.24, which is the crystal frequency. Now if we deduct 10.695, which is the intermediate frequency, we get 455, and that's the other IF. That's how it works out. So can you imagine if you've trying to make the radio do something it's not supposed to do, if you change the reference crystal, the IF's going to be out, so then it doesn't receive properly. Now some radios have got their own reference for the IF. It's on sets using the LC7137 as a synthesizer, and also the ones like the Unidens using the TC9119, is it? 9116, 9119, one or the other, the Toshiba phase-out loop chip. Then they're going to be using the IF reference from that chip. But some of the other sets do need a reference crystal. Right, we'll get back to the radio in hand. Receive's now done. So we want to we want to see what we've now got. So I've turned the volume back up. And there's our 10. There's 12 dB. And we've now got 0.2. So for 10 dB, it's just gone off this scale. Let's go to the next scale, but there's a bit of overlap. It's still 2, you see. It's probably 0.195 or something. And then for 20 dB, 4.6, 0.46. What a super sensitive set. It's another of these best of the bests. You know, you only get this in like 1 in 1,000 sets. Okay, so let's now see where we are with the squelch. So, when I had it at full squelch before, I couldn't have it really, it wasn't really strong enough. So, I wanted to open 100 microvolts, it was about 20 something, wasn't it? The 310, okay, so I need to adjust the preset so that noise disappears. So there's the squelch preset. Now I'm going to adjust the attenuator to make sure it opens at 100. It does. There we are at 100, so it's now set. So now we can read off by putting the signal generator to standby. We can now read off what sensitivity. I've turned the wrong one down. That's RF gain. Set threshold on the radio. Put the signal generator back on. See what it now is. 5.1.51. So threshold is now 0.51. So about where it was before, which is good. And we've now got 100 microvolts there, which is what we want. We've already set that. Now we need to do the S meter. So we're going to put 100 microvolts on the signal generator, and we should now have S9. Well, it's a bit above. Nearly adjusted the wrong one. And there we are, spot on S9. So that had altered. So we've dealt with that tone switch. You can hear the difference now. We just need to do the deviation. So we'll plug into the test set behind. Oh, we'll just see what this says the deviation is. Wow, it says it's 1.8. It might well be right, but because it needs the deviation meter servicing, we'll use the test set behind. At my age, I really can't be bothered sorting that test set out when I've got like another 5. It's the only function not working. Wow, it's about 1.6 or something, so it's about where it was. I want this one to be vertical in its central position, and then we're going to use the meter to set the horizontal one. There we go. So turn that off, plug back into the Marconi test set, and we'll see whether that thinks we've got a peak of 2.5. Well, sometimes it's right and sometimes it isn't. That's why we have that double check. Main meter. Wow, look, it's reading under today. So it was about 1.8, that's true. Which is too quiet. It's now 2.2 with a peak of 2.5 kilohertz. So we're done. We'll test the speaker, we'll test the mic when we do the on the air test. We'll run with the standard replacement mic for the rest of the test. So I'll put this back on. Let's unplug the extension speaker. Internal one's working. Right, I'll take the test equipment off and unplug the test equipment and go onto the aerial instead. Antron 99, mounted just above gutter level, single story building, a normal but industrial level coax, so it's not the CB shop type stuff. The loss of this is about equivalent of the thick stuff which the CB shop sells. So what did we say this cost? Something stupid. It was really stupid, but yeah, several pounds a metre. There's a bit of something on 19. 19 Roger. Hear the tone control work. Tango 21 on the side.
Double there, but I got the gist of that. Yeah, it's our 80s night tonight. We're going to at 8 o'clock at our 80s music night. Not too many weekends left now before I venture off.
If we can get through to him, he's just over 10 miles away.
You don't want us to be stalling anything foreign, does he, Al?
Tango 21 on the side.
He's slightly worried by that remark. I wonder what he's referring to. Yeah. I take it it's Club Eyeball this Wednesday at Havern Park. Carl, is that the plan? Roger. Yeah, Rod's going to be there. Oh, right, well, I haven't met Rod yet.
Oh well, they're not hearing me. So we've got one of those is 10 miles away. I think it's 10.5 miles, and the other one is the far side of Sleaford. He actually used to run the chap called Alan used to run a CB shop at a place called Ruskington. They're all radio hams. We do talk to them all, but they also have a chat with a bit less formality on Sytems band. Right, well there we go. We've actually heard somebody on it, and we'll do an on-the-air test with this, and I've no doubt it's going to be absolutely splendid. It's certainly come like that on the test equipment. So thanks for watching a nice boxed Rotel RVC230 from 1981, which uses the Cybernet 134 chassis.